program, right? So this is for scouts primarily. Let me see if they get everybody back. Right, you know what I need? Yeah, a lot more than that. I get thousands. I need a chair. Can you get a chair? And is there any chair loose?
No, you can sit down back here, sir.
All right, wait. Well, no pushing. All right, just sit where you are. Wait. All right. So sorry about that, ladies and gentlemen. I got a phone call and that knocks me off of Periscope. So there we go. All right. So I was answering some questions on space, and I hope the audio is clear because I'm using my wireless headphones. So hopefully it's coming through okay. So you guys have to let me know, but I'll give you time to jump back in. So what happens, the way this works, people can either watch it live or on replay. So that means after it's already been broadcast, let's say somebody is busy at work and they can't watch it right now. They can go back on the internet, pull it up, and then watch the whole thing over for themselves. Right. So, right, one of the things I was explaining to you guys. Right. Well, before they illuminate, yeah, go ahead.
When they watch it, do you get big bang?
No.
When they watch it,
no. Right. The way it works.
Just get likes and then the likes.
Right. You get likes and you get follows. So the way it works, Periscope is like, imagine this is like a little TV station. So what we're doing right now is we're broadcasting a TV show. That if people like it, they can tell their friends, hey, come and watch this too. And if they really like what they're seeing, then they can follow me, that anything I broadcast, immediately they get a beep on their phone that says, you know, Master Chief is broadcasting something. No. Right, so like they subscribe to me, right? So that way they can follow what we're doing, because I've been working since 2014 from the national camp in Ocho Rios to develop something in Jamaica permanent for scouts. So I'm trying to take my training from America and do something here for you guys. So the interest you have in science and all that, you'll be able to actually use equipment and get training. So somebody who's asking about money, I'll tell you how the money thing comes into it. You'll be able to get a job. You'll be able to be trained in technology and techniques that when you get older, you can get a job doing it. So things like solar, wind power, hydroelectric power, things like that, right?
The things that you have to stop when you reach 12. Stop scouting when you reach 12.
Yeah, but you can still participate on the site, because the site, you could come back as a scout trainer. It doesn't matter. By the time you're even that old, right? You will be able to already have the skills and get a certification and be familiar with it. So if you choose it for a career, you can get it. All right, so people are popping it. So I know you guys will catch it on replay. I got interrupted by a phone call. I apologize. Actually, a customer for the camera systems that I'm pushing to raise funds for the scouting. And this customer is down in Negril. So Michelin, for those of you who follow my scopes, she just linked up a customer in Negril for me to help push the project, because the camera systems are all wireless and battery powered or solar powered, and they're a better alternative than what's already present. So this is going to allow people to be able to help the scouting program, as well as an anti-crime measure, because with the cameras and with the surveillance, Jamaica's now pushing what they call the Jamaica Eye, which is a push to get surveillance cameras all over Jamaica in order to keep down the crime, right? So I'm working on helping the Jamaica Eye project too with these cameras. So it's all connected together in one big push to help Jamaica and help scouting in Jamaica. So yes, okay, so I was explaining the Big Bang to you. So Doppler effect is when you can tell if something's coming closer to you or something's moving away from you by looking at the change in wavelength of something. The wave's either going to get taller or it's going to get pulled out and longer. Now guess how we can use this? Well, guess what else is a wave? Light. Sound and light. Light is a wave. So the Doppler effect also is true for light bouncing off an object. So that car right now, if I was to shine a Doppler, a beam, a Doppler detector at that car, is that car going faster or slower away from me? Right? Think about that car right there. Is that car moving away from me or coming at me? Neither. It's still. So if I bounce a beam, is there going to be any change in the beam? No. But if that car were moving away, it's going to make the light beam I bounce on it come back to me, but drawn out, redder. That's what we call redshift. Say redshift. Redshift. Because the light is shifted to the red. But if that car is coming at me, it's going to squash the beam, just like the police car is going to, it's going to go up. That's blue shift, because it's squashing the light. So we have what? Red shift and
Blue, red shift and
red shift and blue shift. So if I say that kid is red shifted, what is he doing relative to us?
He's moving away.
Oh, touch me. Exactly. If it's moving away, it's going to be red shifted. If it's coming towards you, it's going to be blue shifted. Well, what can we look out at in space that's giving off light?
The sun.
Suns, not just the sun,
the
but
stars.
suns. All the stars. Stars are suns. Suns are stars.
Venus.
So we can look at all the stars and all the luminous objects in space.
Wait, so
Right?
What?
Luminous means they give off light.
What's the name of the
Illuminate.
closest? What's the name of
So
the
luminous
closest?
means giving off light.
What's the name of the closest star?
The closest star, oh wow, you got me. That is Antares, is it? No. Ladies and gentlemen, some research after all. Somebody look up the closest star to Earth. The closest star to Earth. I'm forgetting if it was Sirius. Which was it? Or Antares? I'm not sure. So somebody look up the closest star to Earth. Okay.
Hello. Whatever.
No, various names, right?
I know.
Cygnus. Okay, so there we go. Cygnus
away,
X1. Is that it? All right, I see a question mark. So somebody says Cygnus may be the closest star. But guess what? When we look at the stars using Doppler effect.
From Russia.
Ah, from Russia, welcome. When we look at the stars and we check their light, what can we look for?
I look for
Remember, we just talked about this. Red shift
red shift and
or
blue
blue shift. And if it's blue shifted, it's doing what?
going out, coming,
Right, it's coming towards us. And if it's red shift, it's
going away.
right. Now, guess what? The reason they know the Big Bang exists is because every star we look at, no matter which direction in outer space, they're all red shifted, which means they're moving away.
Even the moon is
Now,
red shifted.
let's think about an explosion. Let's say this is a star, this is a star, this is a star. This star is moving away, and this is the Earth, and these are all the stars, right? So, there's a lesson here. You can learn this lesson too.
So I think I know
Watch
why-
me now.
why it's good.
Right.
All the stars feed into each other and blow up.
Well, watch out. No, it's close, but I'll show you. If this is the Earth, and this star is moving away, that star is moving away, this star is moving away, everything we look at is moving away in time, right? All these stars are moving away. What happens when you reverse time? Turn time backwards,
They will come back. They'll all come back. The blue shifted.
right? They're blue shifted in backwards in time, but they're coming together.
Oh, they come together and then they blow
So
up.
now you see the Big Bang means at some point, if everything's red shifted, going back in time, they're blue shifted, they're all what? Together. So what do we expect in an explosion? If everything goes boom, and this goes away, that goes away, that goes away, this goes away, that goes away, that's going away, that's going away, that tells you that there must have been a Big Bang. At some point, everything is together, it blows up, and they all are moving apart. So when we look out, everything is doing what?
But
Moving away. Moving away, moving away.
I have
Yes.
another question. I've heard
Log on.
I've heard that if you were to split an atom, it would blow up.
Well, splitting an atom is what's called nuclear fission. And that's what's in a nuclear bomb. They use materials that are unstable. And they're breaking apart. And if you do it in a certain way, it amplifies what's happening. And it releases a lot of energy because matter and energy are connected. This has enough energy to blow up this entire place, right, in its atomic energy. So the energy that is being used to hold this together, all the little atoms together, if you were to split it and release that energy, it could blow up everything you see around us. That's the power of energy in matter, that even a little bit of matter can be very destructive. So when you have a nuclear bomb, the bomb doesn't even have to be the size of the tree, maybe a little bit bigger than the tree. But because there's so much energy in matter, when you explode that matter and you split it apart, it releases enough energy to blow up the entire Kingston.
Oh wait, so at least it's not big enough to blow up like a parish.
Well, if the bomb is big enough, If they use enough nuclear material and split enough of it, then yes. Because guess what is another nuclear type explosion?
An atomic bomb.
See that?
The sun.
The sun. The sun is an ongoing nuclear explosion, but it uses a different type of explosion. Instead of fission where you're splitting things apart, it's nuclear fusion. And what makes that happen, here's a quick, is if you get this, you get an extra score. Remember we talked about gravity. If it's heavy enough, it pulls things together. What happens when you pull things together? You can also do what?
You can also take them apart.
What am I doing? Squashing it. Right. So two things that are normally separate can be squashed together so much that they become, that's fusion. You take atomic, but that's things being put together at a very small level, right?
So if you cut a cake into two parts and you put them back together, they'll become back one.
It can happen. You can fuse a piece of cake with enough gravity, squeezing it together. So let's put it this way.
You wouldn't even need a lot of gravity. You just squish it together and it's one.
No, but it wouldn't fuse at the atomic level. You could squash, let's say I could take dirt. I could take this dirt and squash it to the point it grips together. But is it gripped together at the atomic level? No. It's just sticking together. But to get things to grip together at the atomic level, you need extreme amounts of force. And where do you find that? On the sun, because the sun is so big. You see, the sun actually was a lot of matter and stuff, but it got so much stuff squashed into a space that it started to fuse them. And remember, when you pull things together, pulling them apart, you're releasing energy. So when you squish them together, energy is released, and that's why you get the heat, because the explosions make what? What are we feeling right now when the sun's shining on you?
So like a magnet that always stick together.
Mm-hmm.
Yes, the sun is like.
Well, come on this side so everybody can see. Sit over here. Sit. Come on. Yeah. Right here. So. Right.
Yes.
Yes. Well, every. Right. Right. Well, he's got, all right, my friend here, if you can see him, he's just talking about magnetism. Magnetism is another one of the forces of nature. You have a number of forces. They call them the weak force and the strong force. So the force that holds stuff like atoms together and all of this is a different type of force than what is holding together two magnets. That's magnetic force. But that's part of what they call electromagnetism. Who can say that?
Electromagnetism.
Right. That because electricity and magnetism are connected.
So
yes.
Is magnetism basically like welding, like you have to weld a bunch of wool to make a shirt?
Okay, let's step it a little bit back. How many of you know what an atom is like in terms of the structure?
It's like a small
what's inside of the atom?
With a bunch of lines around it and a bunch of other circles on
yes.
the line. It's basically
that's
like
what it looks like when it's drawn. But let me teach you about an atom. Everything, you ever played Lego?
Yes.
All right. Think about Lego. Could I make a car out of Lego?
Yes.
Could I make a boat out of Lego?
Yes.
I could make a whole lot of things out of Lego.
You can make anything
but
with them.
But when you're done, can you break any of those things apart down to the Lego pieces?
Yes.
Right. Well, you, me, the phone, the tree, the leaves, the car are Lego pieces, made up of Lego pieces. And we have a name for those Lego pieces. We call them elements. Let's name them. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Oh, all right. See these kids know their stuff, man. Exactly. These elements are the Lego pieces that make up everything around us. But you could go even deeper than that, because even elements have their Lego parts too, and those are called atoms. So what's in an atom? You have a proton, a neutron in the middle, and then going around it, the electron. There you go. So this is our basic Lego piece for everything that we see around us. Proton, neutron, and electron. But it can change. One proton, one neutron, one electron. You know what we call this? Hydrogen. Hydrogen. Alright, that's oh dear. Alright. So I'm going to run out of power, so I'm going to finish up here, guys. Thanks for watching. You're getting an idea. I'm going to finish up this lecture. I'm going to teach these kids right now about the atom. And I'll scope in again later. Unfortunately, my iPhone not so great on the battery life. But thanks for watching, and we'll tune in again later, and I'll have some follow-up. I'll be doing a scope tomorrow that you guys can catch up on. But feel free to follow, and I'll stick that in here. So follow and share. And I will again explain more of some of the projects I'm working on. And in the meanwhile, you guys can go back in my scope history and see all of the various scopes I've done with the scouting program and with other things that I'm helping to raise awareness and to raise funding for the permanent scout site in Jamaica. So guys, say bye to everybody.
Bye.
Bye. Thanks for watching, and we're going to continue here at the St. Andrew District Rally
Goodbye
while
to you,
we're waiting on the
Luck.
intermission to end. So,
Goodbye to you, Rude Luck.
all right. Thanks a lot for watching, guys. And again, don't forget to keep following and subscribe and retweet, okay? And we'll see you later. So we'll continue this lesson on atomic energy and the structure of the atom. And we'll be back later. Thanks. Bye-bye.